Okay, so picture this. You're just cruising down the highway, right?
Yeah.
In your self-driving car, enjoying the scenery, everything's going great.
Yeah.
And suddenly, the AI driving the car, it totally misreads a road sign and veers right into oncoming traffic.
Oh, man.
Yeah, it's
Scary thought.
a scary thought. And it's actually the kind of nightmare scenario
Yeah.
that researchers, they lose sleep over this stuff.
Yeah.
When it comes to these vision language models.
Oh, yeah. VLMs.
VLMs, exactly.
Absolutely. I mean, they have this incredible potential,
Right.
to really change everything. Transportation, healthcare.
Huge.
But they got to be reliable. I mean, that's paramount.
That's the key. And our listener here sent us this paper
Yeah, this is a good one.
on a framework called Critic-V.
Uh-huh.
And it's all about making these VLMs more trustworthy.
That's the goal.
Yeah. So let's dive in and see what it's all about.
Okay, let's do it.
We know you're really interested in the practical applications of this.
It's exciting stuff.
We'll make sure to hit on those too.
Definitely. It's a clever approach, for sure.
Okay.
The core issue with even the most advanced VLMs
Right.
is they can still make mistakes.
Yeah.
They might, hallucinate details, misinterpret what you're asking them to do.
Yeah.
Or even just get basic facts wrong.
Yeah. I saw that in the paper.
Yeah, it was a great example. Like, there was one where a VLM, it was shown, picture of Portland, right?
Okay.
And it said that was the capital of Oregon.
Oh, wow.
Yeah, when it's actually Salem.
Wow. So we have these powerful
Yeah.
VLMs
Yeah.
that can see images,
Right.
understand them,
Yeah,
but they make these errors
they do.
that could be a real problem
Huge problem, yeah.
out in the real world.
Big time.
So what's the typical way to fix these flaws?
Well, traditionally,
Yeah.
researchers have focused on improving the internal mechanisms of the VLM.
Okay.
Tweaking the algorithms, fine-tuning all those parameters.
Right. So under the hood stuff.
Yeah, exactly. But it can be so hard. It's like you're trying to rewire a machine while it's running.
Yeah.
It's not always effective.
Right. And then even finding the source of the errors
Oh, yeah, that's hard.
must be so difficult.
Incredibly difficult, yeah.
So that's where this Critic-V comes in, right?
That's where it comes in, yeah.
Totally different approach.
Totally different.
Okay. I'm interested.
So Critic-V, it kind of steps outside that black box,
Okay.
of the VLM, and it introduces this external feedback mechanism.
Okay.
And it's inspired by the actor-critic model,
Right.
from reinforcement learning.
Yeah.
But instead of rewards and punishments, you have these natural language critiques.
Wait, natural language. So the feedback is actually in sentences.
Exactly. Sentences and phrases.
Oh, wow.
A teacher correcting a student's work.
Okay. That's pretty cool. So it's a two-part system.
Yes. 2 parts. First, you have what they call the reasoner,
Right.
which is basically the VLM itself
Okay.
that's generating the responses to, whatever the prompts are.
Yeah, yeah.
And then you have the critic,
Uh-huh.
and that's a separate VLM
Oh, wow.
that acts as a quality control expert.
I like that.
Yeah.
So it's the reasoner gives an answer,
Right.
and then the critic's hey, you missed half the fruit in that picture.
Yeah, exactly. Or there aren't any motorcycles in this image.
Right, right.
So that part of your description is wrong.
That's so cool.
It's neat, right?
But, I mean, wouldn't there be limitations to
Yeah.
this natural language feedback? It could get really long-winded.
It could.
Or even miss, subtle errors.
Yeah, and the researchers, they know that.
Okay.
I mean, how effective the feedback is really depends on the critic being able to, explain the error clearly, concisely. So, yeah, there's definitely room for improvement.
So it could get even better
Oh, yeah.
at giving that feedback.
Potentially, yeah. More insightful, more nuanced.
Wow. Okay, but how do they even train this critic to be so discerning?
Yeah, that's the question.
I saw in the paper there's this technique called VEST.
Right, VEST.
What's that all about?
So VEST stands for Vision Error Insertion Technique.
Okay.
Basically, it's a way of training the critic
All right.
by, get this, intentionally introducing errors into the image descriptions.
Oh, wow.
And then they ask different VLMs to critique those flawed descriptions.
So they're messing things up on purpose.
On purpose. Think of it like boot camp
Okay.
for the critic, where it's learning to spot all those inconsistencies and inaccuracies.
So they're trying to trip it up
Yeah.
to see if it can catch it.
Exactly.
That's fascinating. What kind of errors do they even insert?
Okay, so get this. They actually use GPT-4o, a powerful language model, to insert like these realistic sounding but totally false details into the descriptions.
Oh, wow.
For example, they might describe the support structure of a public market sign as a giant golden octopus.
Wait, a giant golden octopus?
Instead of the actual metal beams you see in the picture.
That's hilarious.
It is, right?
So it's like spot the fake for the critic.
Exactly. I'm
starting to see how this would make it really good.
Yeah.
At identifying errors. But how do they know which critiques?
That's a good question.
Are like the best ones.
Right. So that's where their scoring method comes in.
Okay.
They use a combination of the Jacquard index, which measures like similarity between sets of words.
Yeah.
And then a GPT-based evaluation to rank these critiques, based on how clear they are, how concise, how accurate.
Right.
So this creates a data set of preferred and disfavored responses.
Oh, okay. I see. So they're not just throwing any old critique at it.
Nope.
They're actually teaching it what good feedback looks like.
Exactly.
I like that.
That's the idea.
And then they use this to train the critic model, right?
Right. Using something called direct preference optimization, DPO.
DPO. Okay, so what's that all about?
So it's a really interesting training technique, actually.
Okay.
Because instead of, giving the model a specific reward for each correct answer, you're actually training it to recognize patterns and preferences. It's kind of like, imagine showing an art student hundreds of paintings and saying, these are the ones the masters created. Figure out what makes them great.
Oh, I like that.
Right.
So it's more about like understanding quality than just memorizing right and wrong answers.
Yeah, it's about developing that intuition.
But doesn't that make it a little subjective?
Well, that's a good point.
Like how do they make sure the critic's feedback is consistent and objective?
That's where the data set comes in.
Okay.
The researchers were very careful to create a data set. Yeah.
That reflects a diverse range of critiques, perspectives.
Okay.
And they also used, those quantitative metrics like the Jacquard index.
Right.
To make sure there's some objectivity in that scoring process.
Okay, so there's a balance there.
Definitely.
Between developing that intuitive sense, but also grounding it in objective measures.
Exactly.
All right, so let's move on to how these two actually work together.
Okay.
The reasoner and the critic. Is it just like a one-time thing?
No, it's actually much more dynamic. It's kind of like an iterative dance.
Oh, I like that.
The reasoner generates the initial response to a prompt.
Yeah.
The critic analyzes it, provides feedback, and then the reasoner actually takes that feedback into account and generates a revised response.
So it can go back and forth.
It can, yeah. It can go back and forth
until
it comes up with something that's, satisfactory.
So it's not just pointing out errors.
It's like guiding the reasoner.
It is, yeah.
To a better understanding.
Toward a more accurate and nuanced understanding. Exactly.
Right. Okay, so this all sounds really cool in theory.
Yeah.
But does it actually make a difference?
Well, the results are really impressive, actually. They tested Critic-V on all sorts of different VLMs. Including like open source models like Llama, closed source ones like GPT-4V.
Oh, wow.
And across all these different benchmarks, like real world QA, Math Vista, Science QA.
All right.
And in almost every case, Critic-V really helped.
So it actually works.
It does, yeah. It significantly improved the accuracy and the reasoning abilities.
So it's not just like a theoretical concept.
Right.
It's actually working?
It works in practice, yeah.
Okay, so instead of like listing off all the benchmarks.
Right.
Can you give me like an example?
Sure. So in one example, the prompt was asking the VLM to identify the capital of Oregon based on this image of Portland.
Right.
So the VLM, without Critic-V, it said Portland.
Oh, of course.
But then with the critic giving that feedback, it was actually able to correct itself.
Wow.
And identify Salem as the capital.
That's so cool.
Right.
Even though it's a simple example,
yeah,
it shows how powerful it can be.
Exactly. It helps it overcome those factual errors.
But what about like more complex stuff?
Right.
Like those math or scientific concepts?
Yeah, so on those math-heavy benchmarks, like Math Vista and MathVerse, Critic-V showed some of the biggest improvements.
Really?
Yeah, like accuracy boosts up to 17.8%.
Wow.
And 10.5% respectively.
Okay, those are big gains.
Yeah. It suggests that that step-by-step feedback from the critic is really helpful for those complex reasoning processes.
Okay, so those numbers are really impressive.
Yeah.
But is this something that could be scaled up?
That's a good question.
Like, could it work for real-time video?
Well, that's one of the limitations right now.
Okay.
The process, that back and forth can be computationally expensive.
Right.
So there's definitely a trade-off
Okay.
between accuracy and efficiency.
So not quite ready for self-driving cars yet.
Not quite yet, no.
But those math results make me think about, like, scientific research.
Oh, yeah.
Or data analysis. Could it help researchers make new discoveries?
Absolutely. I mean, imagine a scenario where a VLM is analyzing images from a telescope or microscope.
Yeah.
The critic could help it identify patterns, anomalies, maybe even breakthroughs.
Wow.
That humans might miss.
That's a really exciting thought.
Yeah.
But let's be realistic. What are some other drawbacks to this approach?
Right.
We were just talking about some drawbacks to Critic-V.
Right. Well, besides the computational cost, another challenge is like making sure the critic's feedback can be applied broadly.
Okay.
Can a critic that was trained on one kind of task, say image captioning, actually be effective at critiquing something totally different?
Right. Like math.
Yeah, like mathematical reasoning.
That makes sense.
It's a question that researchers are looking into.
If we want it to be really useful across all these different applications, it needs to be able to adapt.
Right.
Transfer that knowledge.
Totally.
But I'm also curious about, the ethics of this. Having AI critique other AI, is that a concern at all?
It's a really important point.
Yeah.
Though, to be fair, it's kind of beyond this particular paper.
Okay.
This paper is really focused on improving that reliability, the accuracy, not so much the philosophy of like AI evaluating AI, but as this technology keeps developing, it's a conversation we need to have.
For sure. So we've talked about the problem, the solution.
Yeah.
We've looked at how they tested it, the results.
Right.
What about the researchers? What are they saying about all this?
Well, they really emphasize that this is about making VLMs more reliable.
Okay.
It's not just about, making them smarter.
Right.
It's about making sure you can trust them.
Especially for those critical situations.
Absolutely. And they see this as a way to move beyond just tweaking the inner workings of the VLM.
It's more about like teaching them to think critically.
Yes.
Almost like a human would evaluate their own reasoning.
Exactly.
That's fascinating.
And they believe this is a key step in creating AI that's not just intelligent, but self-aware.
Right.
Able to spot potential errors.
Or biases.
Yeah, in their own thinking.
Okay, so what's next for them?
Well, they're really interested in figuring out how to make Critic-V more efficient.
Yeah, because running 2 VLMs at once.
Right. It can be pretty demanding.
It's a lot of computing power.
It is, especially for, those real-time applications.
Yeah.
So they're trying to streamline it, maybe develop smaller, more specialized critics that can give that targeted feedback without needing so much power.
That makes sense. And also making it more adaptable.
Oh, yeah, for sure.
To all those different tasks.
Exactly. Maybe through transfer learning.
Right. That's interesting. Makes me wonder if this Critic-V could be used on other types of AI, not just VLMs.
That's a great question, and one they're actually thinking about.
Really?
Yeah. Imagine using these critic models to improve language models.
Yeah.
Robots. Even decision-making systems.
Wow.
The possibilities are huge.
So many possibilities. This has been so insightful.
Yeah, it's fascinating stuff.
Really exciting to see how AI is advancing.
It is.
Not just in intelligence, but reliability, trustworthiness, even self-critique.
Yeah.
Thanks for diving into this with me.
Happy to be here.
This has been The Deep Dive.
See you next time.
Thanks for listening.